Hi, I'm Wechat on Tablets of Primary 6, right now here. We are still going on with our theoretical mechanics at Chapter 1, Kinematics. For these parts, we have already said about 6 of the most basic things that we need to know for theoretical mechanics. So right now here, we're going on with the 7th part. Okay. All those before, we have those like distance, we have those average speed, average velocity, those different things. Right now, it's something right at a moment, or you can say it's right at that instance, or right at that instant. So this is something that is called instantaneous something. For the parts behind, okay, so we're going to have speed for this time. So this is for instantaneous speed. So it is a speed right at that moment. So right now at this part, let's just say we have one of these axes. Well, let's just say it is an x-axis. Then, of course, it's origin for the 0 point. Then what if we have this particle that moves? This particle might move from this part to here, and you say it's x, or move from some other parts. Right now here, we're not so sure about that part. But all that I'm going to give is that this distance between this particle and this origin, the distance between this would be x. Okay, we have this distance as x. Then we have to give a definition for this x about how to use different parts like the time to find x. So to find x for this part, we could use this time square, the square of this time. Then after that you add 2. You can use this part. So we have this x, okay, and this time. But how about that speed? So speed, we're going to use this v. Now speed. Speed at this part. This is about instantaneous speed. So for one little part of this x, it takes a little bit of time. Now we have to limit this. We limit this at this delta t approaches to 0. Okay? So in another way to write this, we can just write it as dx dt. Okay, we can write it as this part. But after that for this part, dx dt. So we're using that as the speed. So that means you also have to differentiate the other parts. Is we differentiate on one side this x with respect to t, so the other side also differentiate with respect to t. But all that you're going to get is this 2t. So this velocity, this speed is actually 2t, 2 times the time. So we can just give a few of these, like for example, if the time at this point is 1 or 1 second, then after that, this speed, according to this, you'll get 2. Then this part, beware of this is meters per second. Okay, so here you get 2 meters per second. Then what if t is 2 seconds? So this speed, then it will be 4 meters per second. For 3 seconds, you'll get 6. And for 4 seconds, you will get 8. Then for 5 seconds and all those different heights, well, we can just listen and so on. So for this part, we're going to have something else right now. So we do have all these different speeds. But how about, let's draw something about x at its position with respect, or draw a graph of this x against this time. So here, beware, now this part is not the x-axis. This axis right now is the time. So having this against the time, then this part will be our x-axis. Now this x-axis is the position from this origin just now here. So beware of this. This is the position against this time. So we have to see when this time it is 0. So where do the x start from? Now according to this part, it starts at 2. So let's just say here is a 2. Then after that, if we have 1 for the time, 1 second, this position, it will be at 3. Okay, so it is around this point. Then if this part is 2, you get 6. Okay, so it's around that point. So then after that, we'll just connect all of these into a graph. At the point, it cannot go inside. Okay, so you get a graph like this. So this is the type of graph that you'll get. This type of graph, you call it a quadratic curve. Okay, as this is just a curve. But beware, this particle travels in one direction, or you can just call it in 1D. And this is what we have drawn out, is only how far it has gone according to time. It is not actually, it goes in this direction, which becomes in a two-dimensional way, but instead it's a one dimension. So at these different parts, so what can we calculate from here? Let's see. So what is these V? These V, what do they represent on this graph? Let's see about that. So when time is 1, this part you have 2. What if we draw this tangent line? So it goes intersect at this one point, and this tangent line, then you can draw this horizontal line, this horizontal part. Then you have this angle, and you can call it theta 1. Okay, this part you call it theta 1. How about, since it's a tangent line, how about tangent theta 1? Tangent theta 1. For this part, it will be this 2. At this part, it is this 2. Then how about for 2 seconds? Okay, for this part, it do not intersect anymore. Okay, like this. Then after this part, you call it theta 2. Like this. Wait, let me just write that more. Okay, this part you call it theta 2. Then how about tangent theta 2? Okay, tangent theta 2 at this part will just be for this 4. Okay, so you have these. But wait, what if I just pick from different timings? Like, we can find the speed of from, let's just say 1 second to, how about 2 seconds first, from simple parts. So once the first second to the second second. So the total distance that it would have traveled, so from this 1, so you get 3. Then from the 2, you get 6. So it is a 3, and this part would be a 1 second. So it gets 3 meters per second. Then what if this part is from 3 to 4? Like we can have 1 to 2, we can have 3 to 4, like those different kinds. So when this part is 4, so you sub it inside, you'll get 18. Then 3, you put it inside, you get 11. So it is 7 over 1. So which is just 7 meters per second. So we have these. What if I just go for more? Like from 1 to 3. V from 1 to 3. So at this part, 3 is 11. So you use that to minus 3. So it will be 8. But this part, it will be a 2-second time. So yes, over 2. Then what you get here will be 4 meters per second. But at this part, then what do all of these represent on this graph? So let's just say it is from the first second to the second second. So basically we draw this line across which intersects this part at this point and here. Now that still we find the tangents. So let's just say here, this would be a theta 3. Okay, this part is a theta 3. Then the tangent of theta 3. So it is from 1 to 2. So here you get 3. Okay, so that means for this first part over here, on this part, they can represent the tangent lines. But for this part behind, they can represent the secant lines, and also this part goes on and on, since you can just extend this out forever. Okay, so that's what you have for here. So that means at this part, oh wait, this time here 2, 4, 6, 8, 1 and 2. What if you just take 2 and 4, 2 and 4, then divided by 2, you also get 3. 6 plus 8 divided by 2, you get 7. Then for this part below, 2 plus 4 plus 6 divided by 3. Wait, you still get 4. So all of these just match perfectly. But how is that right? Well, we'll say about that in future lessons, okay? So if you want to know more about these, like how they can happen, you can watch those future lessons. So for these different parts, if you have realized one thing, why we have used this meters and this seconds is that we are just using the SI units. So these parts are all using different types of SI units. So this part will be for this lesson of instantaneous speed. Okay, so for these parts, I hope that all of you can understand so far. So if you like our videos, don't forget to subscribe to our channel. We'll see you in the next lesson. Thank you for your watching.